Hey, hey. So this is 2013 question number 4. And we're given a picture of the derivative and we want to answer some questions about a function. So in part A, we want to find the values for x in which this function f has a local minimum. So if we have a local minimum, so a local minimum happens when our derivative changes from negative to positive. So when does our derivative change from negative to positive? So here, our values are positive, they become 0, but they're still positive. Positive to negative, that's not what we're looking for, and then negative to positive. So here is where we're going to have a local minimum. F has a local minimum at x is equal to 6, since f prime and this was part A. So since our derivative changed from negative to positive, the function had a local minimum. Determine the absolute minimum. Whenever you want to have an absolute minimum, you need to check not only the local minimums, but also the endpoints. So our endpoints are going to be 0 and 8, and then we have this local minimum at 6. So t, or x rather, sorry, and f of x so 0, 6, and 8. We were told that f of 8 is equal to 4. Now if we want to find f of 6, and it doesn't matter the order in which you find it, but from 8 to 6 we have this area of 7, but since we're starting at 8 and we're going to the left, even though this area is above the curve, because we're starting to the right and going to the left, we're going to be subtracting that 7. So 4 minus 7 is equal to negative 3. For 0, we know that at 8 we have a value of 4. Subtract the 7, and now this area is underneath, but since we're going from the right to the left, we're going to add 3, subtract 6, subtract 2. So we get 4 minus 7 plus 3 minus 6 minus 2, which is equal to negative 8. So comparing these, our absolute minimum happens at 0, and it says determine the absolute minimum, so we know that it happens at 0, and the absolute minimum value is negative 8. So f has an app of negative 8 on that interval from 0 to 8. Okay, so on what intervals is the graph both concave down and decreasing? Concave down in this was the start of part B. So concave down, we're looking at a picture of the derivative. And increasing when is f prime positive or greater than 0? So we're only looking at values when the derivative is greater than 0 and we want it to be decreasing. So here our values are greater than 0 and these are decreasing. So from 0 to 1, that fits both criteria. From here to here, we are greater than 0, so the function is increasing, but f prime is not decreasing, so this doesn't fulfill the concave down criteria. From here to here, we're positive and also decreasing. So again, this would be another case when we're concave down and increasing. Since these aren't even positive, we can rule these out, and these are positive, but they're not decreasing. So the only values that we care about are from 0 to 1 and then from 3 to 4. So f is concave down and increasing on the intervals 0 is less than x is less than 1, and that's that from 3 to 4. So since f prime is both decreasing and positive, we fulfill those criteria on those two intervals. All right, lastly, the function g is defined by f of x to the third. Find the slope of the line tangent at this x value. So if we want to find the slope, g prime of x will be equal to 3 times f of x squared times f prime of x. So that's a case of the chain rule. If we want to find this at an x value of 3, g prime of 3 will be equal to 3 times f of 3 squared times f prime of 3. Well, in the part D itself, we were given, I'm going to zoom out and then kind of like zoom back in. It's going to be crazy. So we were given f of 3 to be negative 5 halves. So f of 3 is negative 5 halves. And then what is f prime at 3? Well, we're looking at a picture of f prime. So f prime at 3 is equal to 4. So g prime of 3 is equal to times 4. When you square a fraction, both the numerator and the denominator get squared. These 4's are going to cancel. 3 times 25 is 75. Okay, so that was 4. Almost there.